All right, hello once again. This is Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD 1000 Web Development Technologies class, I've been creating a series of video presentations that's based on the Mozilla Developer Network Learn Web Development series. I'm in the JavaScript section, and we're still talking about asynchronous programming. Now, in the last tape, we went over set timeout and clear timeout. Now we're going to go over set interval. As it says, set timeout works perfectly when you need to run code once after a period of time. But what happens when you need to run code over and over again? And that is where set interval, as it says, comes in. It works in a way similar to set timeout, except that the function you pass is executed repeatedly at no less than the number of milliseconds given by the second parameter rather than once. All right, you can also again pass parameters as required in your set interval call. So it says, let's look at an example right here. Now this example, as it says, creates a new date object, extracts a time string out of it using the appropriate associated function, then displays it in the UI. Then it runs the function again 1 second later. So it looks as though this will work like a clock. So let's see. Again, I like that alarm clock one that we just did. So let's see. All right, so let's save. Bring this back up again and refresh. And display time doesn't like what's in line 12. All right, it's got this demo, which doesn't look like it's being set anywhere. See the source. That always helps. Let's just grab the source from here, copy it. We'll put it in right here then. Save. And refresh. And if you look, we've now got, all right, we now have the time that is showing up on screen. And it's being updated every second. All right, I like this example also. I'm going to save this one. And I'm going to call it clock.html. Okay. So we've got clock and we've got alarm clock. And this bounce thing does not exist. You still want it? No. That one doesn't exist. You want it? No. All right, so we will put whatever we do next right in here. All right. Just like set timeout, set interval returns an identifying value that you can use later when you need to clear the interval. All right. Set interval, as it says there, keeps a task running forever unless you do something about it. What does that mean? Well, again, it would be like if you could imagine that what was happening was if your snooze button would run every 9 minutes and it would just keep going forever. All right. So as it says, you'll probably want a way to stop such tasks. Otherwise, you might end up getting errors when the browser can't complete further versions of the task. All right. It might, after a while, it might not make sense to run the code anymore. You can do this the same way that you stop timeouts by passing the interval, the identifier in, and calling clear interval rather. So this is clear interval, and if you noticed before, that was clear timeout. So it says we've got a challenge for you. Take a copy of this set interval and modify it to create a stop. This would be a terrific one for you to try. All right. Again, are we going to do any of these in class? I don't know. Let's just see as we get going. So they give you some hints, etc. I'm not going to run through any of that right now. Okay, things to keep in mind about set timeout and set interval. All right, it says there is another way to use set timeout. You can call it recursively to run the same code repeatedly rather than using set interval. And actually, that should make some sense. All right. It says compare the example to the following one that uses set interval to do the same. So what do we got? I equal 1, set timeout, set interval, function run, function run. All right, but here we're setting the timeout, and here we're doing it via an interval. So how do these two things differ? As it says, the difference between the two versions of the code above is a subtle one. Recursive set timeout guarantees that the given delay between code execution completion and the next call. The delay will start counting only after the code is finished running, therefore excluding the time it took to run the code. In this example, the 100 milliseconds will be the delay between the run code finishing and the next run call. On the other hand, set interval does things differently. The interval you choose includes the time taken to execute the code. It says, let's say that it takes 40 milliseconds to run, then the interval ends up being only 60 milliseconds. When using set timeout recursively, each iteration can calculate a different delay before running the next iteration. In other words, the value of the second parameter can specify a different time. It would be as though maybe with your alarm clock, the first time you press snooze, it would go off after 9 minutes, the next time 8 minutes, the next time 7, etc. All right. When your code has the potential to take longer to run than the time interval you've assigned, it's better to use the recursive timeout than the recursive set interval. As it says, this will keep the time interval constant between executions regardless of how long it takes to execute, and you won't get any associated errors. Using 0 as the value for set timeout schedules the execution immediately after the main code has run. We already looked at this. All right. So try this one. In fact, let's do the see it live. And you'll notice one of the key takeaways, at least in this, is these are two different alerts. All right. So it is doing the hello first, because even though there's no time here, it's got to go and check first to see if there's anything on the execution stack. There is, it does this, and it comes back and it does that. So again, it is in the right order. They mention here that this can be useful in cases where you want to set up a block of code to run as soon as all main code stuff is finished executing. All right. Okay. Clearing with clear timeout or clear interval. Both these two methods use the same list of entries to clear from. Interestingly enough, it says this means you can use either method to clear either a set timeout or a set interval. You should always use one with the other. So if you have a set interval, you should have a clear interval, and a set timeout, you should use a clear timeout. As it says, it avoids any confusion. Ideally, it will. All right. Next, we've got the request animation frame. And I think I'm going to at least start that right now. So, as mentioned there, request animation frame is a specialized end. So remember that enqueuing is putting something on that execution stack, whereas dequeuing is taking it off. All right, so it's a special enqueuing function created for running animations efficiently in the browser. As it says, it runs a specified block of code before the browser next repaints its display, allowing the execution to be paired with the device's display frame rate. It was created in response to perceived problems with previous async functions like set interval, which, for example, does not run at a frame rate optimized for the device, dropping frames in some cases, so it can look amateurish, blotchy, whatever you want to say. They also lack some optimizations suited for animations like stopping the execution if the tab isn't active or the animation is scrolled off of the screen. All right. It says you can find examples of this elsewhere in the course, so there are some links if you're interested in that. The method takes an argument as a callback to be invoked before the repaint. This is a general pattern that you'll see. Okay? It says there that the idea is to define a function in which your animation is updated, and sprites are basically what you're going to be trying to move across the screen or whatever. The score is updated, the data is refreshed, or whatever. Then you call to start the process off. At the end of the function block, you call request animation frame with the function reference passed to it as a parameter. This instructs the browser to call it again on the next repaint. And you do this continuously. If you want to perform some kind of simple DOM animation, these are probably, CSS animations are probably faster. If, however, what you're doing is more complex, it says the request animation frame is better. And again, how do you know? You try different things to see which one appears to work better. Okay? The smoothness of your animation is directly dependent on your animation's frame rate and is measured in frames per second. The higher it is, the smoother your animation will look to a point. Since most screens have a refresh rate of 60 Hz, the fastest frame rate you can aim for is 60 frames per second when you work with browsers. More frames means more processing, and as it says, it can often cause stuttering, also known as dropping frames or jank. If you have a monitor with a 60 Hz refresh rate and you want to achieve 60 frames per second, you have about 16.7 milliseconds to execute your animation code to render each frame. All right, as it says, they're telling you that so that you are mindful of the amount of code that you try, because again, you're not going to be able to execute hundreds of lines of code in 16.7 milliseconds. All right. Request animation frame, as mentioned here, always tries to get as close as possible to this magical 60 frames per second value as it can. Sometimes it's not possible if your animation is complex or you're running it on a slow computer. But it always does the best it can with what you give it. All right, so how does this differ from set interval and set timeout? All right, looking at the code below, it says this is how you would do the same thing using set interval. You'll notice that again, it's right up at the top, where here it's at the bottom. Okay. You don't specify a time interval for a request animation frame. It runs as quickly and smoothly as it can based on the machine, etc., what code you're trying to run, etc. It says the browser also doesn't waste time running if the animation should be off screen. Maybe you're having it fade into view or come into view from the left or the top or whatever. Okay. The actual callback passed to the request animation frame function can be given a parameter. a timestamp value that represents the time since the request animation frame started running. This is useful as it allows you to run things at specified times at a constant pace, regardless of how fast or slow the device might be. As it says, it's supported in more recent browsers than is Set Interval and Set Timeout, which has been around almost forever. Interestingly, it is available in IE 10 and above. So unless you need to support older browsers, there's little reason not to use it. All right, so it says enough examples. Let's talk about some theory. And I want to check my time before I go into this. Yeah, we're good. Let's finish up this one, and we'll try to finish up the rest of this in our next video.